that the oscilloscope can draw graphs of two variables, such as characteristic curves? This video shows how the XY mode is used to do that. To observe a graph, we select the XY mode. Note that channels 1 and 2 are now referred to as channel X and channel Y. In this mode, there will be no time domain observations. The voltage magnitudes of channel X and Y are now being represented by X and Y axis. Now you can see a dot on the screen. That means there is no signal on each of the channels. That's why there's no deviation along X and Y axis. Let's take a familiar example. This circuit is designed to observe the VI characteristic of a diode. As you know, we must change the voltage of the diode to observe the variation of current. So, we connect a linearly varying voltage source, which is a triangular signal. Here, we need to find signals proportional to voltage and current of the diode. As you can see, the voltage can be measured across points A and B. That is VAB. What about the current? I think you remember that the oscilloscope is a voltage measuring instrument. So we cannot directly observe a current. That means we need to find a voltage signal which is similar in shape to the current signal. In this circuit, we can find it as the voltage across the resistor. That is points B and C, VBC. The oscilloscope has only one reference point. That means we must select a common point to both signals as the reference. It should be point B. Now, we connect voltage signal to channel X and current signal to channel Y. By adjusting the scales and position controllers X and Y, we can observe a clear curve. Have you noticed that the curve looks inverted? Do you remember the circuit diagram? We connected point B to the reference. Therefore, the signal across the resistor is inverted. This appears as VCB instead of VBC. To correct this, we can use the inverting option of channel Y. Now, we get the proper VI characteristic curve of the diode. This is the forward biased region and this is the reverse biased region. Of course, we can't see the breakdown region. Another application of the XY mode is to measure the phase difference between two sine waves. Let's connect two signals to channel X and Y. There's a phase difference you can see in the time domain. Now, we select the XY mode. You can see an ellipse. measure the phase shift, first we need to center this figure. Let's put input selectors of both channels to ground. In other words, we stop the deviation along both x and y directions. The result is a dot. Adjust the x and y position controllers to bring this dot to the origin point of two axes. Now the figure is centered. Now we need to obtain the two distances A and B as shown in the figure. The ratio of A to B is the sine value of the phase angle between the two signals. Thereby we can calculate the phase difference. The distances A and B can be taken either vertically or horizontally. This example shows 45 degrees phase difference. This is how the ellipse changes its skewness with the phase difference. Zero in phase signals, 30 degrees, 45 degrees, 60, 90, 120, 135, 180 inverted signals. Would you like to see some interesting graphics on oscilloscope? Let's observe sine waves with different frequencies. There we can see some patterns. These are called Lissajous figures, also commonly pronounced as Lissages. If one frequency is an integer multiple of the other frequency, we can see a static figure. Even we can determine the frequency ratio by counting the number of loops in it. In this video, we have learned how to use XY mode to observe characteristic curves and measure the phase difference between sine waves. Also learn how to connect reference point and use the inverting option. Please join with our next video.